All right, today's goal: the learner will understand and perform operations with complex numbers. So, key concept: the square root of a negative number. If r is a positive real number, then the square root of negative r equals I times the square root of r, because it's imaginary. So, for example, the square root of negative 3 is I squared 3. By property 1, that it follows that I times the square root of r, that quantity squared, is negative r. Okay, so big thing that you need to know. I squared is equal to negative 1. Okay, so just remember that. So now we have to solve some equations here. Well, take the square root. It's the square root of a negative, so there's no real solution, but you would say x equals plus or minus the square root of negative 13. But since it's negative, you bring the I outside. So you would say x equals plus or minus I times the square root of 13. You can't simplify square root of 13 at all, so it's just an imaginary solution. But no different than what we've been doing. So let's look at the next. Here, you got to subtract the 11. Get x squared equals negative 8. Let's clean that up. Square root both sides, so you get x equals I times the square root of 8. Well, but square root of 8 you can simplify. So remember, you can do x equals I times the square root of 4 times the square root of 2. Well, what's the square root of 4? 2. Oh, plus or minus. Plus or minus. Almost pulled the error there. So you get plus or minus 2I square root of 2. So here were the two solutions so far. So let's take a look at some other examples here. Alright, here we go. Subtract the 33. So you get the negative 30 divided by the 5. You get x squared equals negative 6 square root. So you get x equals plus or minus I times the square root of 6. You cannot simplify that at all. So there are your solutions, okay? Alright, let's take a look at some more. Complex numbers. A complex number written in standard form is a number a plus bi, where a and b are real numbers. The number a is real part of the complex number, and the number bi is the imaginary part. If b cannot equal 0, then a plus bi is an imaginary number. If a equals 0 and b cannot equal 0, then a plus bi is a pure imaginary number. The diagram shows how different types of complex numbers are related. So real numbers, a plus 0i. Imaginary numbers. You have a plus bi where b cannot equal 0. So you have 2 plus 3i, 5 minus 5i, and then the pure imaginary numbers, negative 4i, 6i, where there's no real, just imaginary. Two complex numbers, a plus bi and c plus di, are equal if and only if a equals c and b equals d. For example, if x plus yi equals 5 minus 3i, then x equals 5 and y equals negative 3. Okay? The sum and differences of complex numbers. To add or subtract two complex numbers, you add or subtract their real parts and their imaginary parts separately. So if you have a plus bi plus c plus di, you have a plus c plus b plus d, I. If you have a plus bi minus c plus di, you have a minus c plus b minus di. Okay, now, something else. Here's a table you need to get familiar with. See, the reason you have I to the first equals I I squared equals negative 1. I to the third equals negative I. And I to the fourth equals I. See how they're starting to repeat themselves? Or sorry, I to the fourth doesn't equal I, it equals 1. Now, look what I to the fifth equaled. I. And then I to the sixth equaled I squared, but we know that equals negative 1. I to the seventh equals... So what you need to do is you divide the exponent by 4 and focus on the remainder, because that's what it is. Okay? And I to the 0, anything to the 0 power is 1. And then see how they repeat? That's something that will help you. So let's look at an example of that. So we have these. So watch. Let's go with some old school division. Well, 4 goes into 27 6 times, with a remainder of 3. So that's I to the third power, which is negative I. So you go 99. How many times does 4 go into 19? 4. Another remainder of 3, so that's I to the third, which is negative I. Now you can do this in your head or just figure it out. Now let's see, like, this is remainder of 0, so that means it's I to the fourth, or sorry, yeah, I to the remainder of 0 is the fourth one, so you get 1, okay? These are things you'll need to practice. Here's some more vocab you're going to need to know. Complex conjugates. Two complex numbers of the form a plus bi and a minus bi are called complex conjugates. The product of a complex conjugate is always a real number. For example, the quantity 2 plus 4i times the quantity 2 minus 4i equals 4 minus 8i plus 8i plus 16, which equals 20. You can use this fact to write the quotient of two complex numbers in standard form. Okay? So just remember that for some future examples here. Alright, it says write the expression as a complex number in standard form. So we need to get it down to just a plus bi. So when there's plus in the middle, don't worry about it. You can just get rid of or distribute the plus sign. So you get minus 6 plus 7i. Then treat it like it's a variable. What's 9 minus 6? 3. Negative I plus 7i plus 6i. Done. Let's take a look at another. Subtraction. First one still stays the same, so you have 3 plus 7i. Distribute the negative. Minus 8 plus 2i. Now what's 3 minus 8? Negative 5. 7 plus 2? 9i. Standard form. Done. Let's take a look at some other problems. Okay, it says write the expression as a complex number in standard form. So we still need to write it in a plus bi. So we need to distribute 15 minus 3i plus 5i minus I squared. So that's 15 plus 2i. Well, minus, but I squared is negative 1. So that's going to change to positive 1. So you get 16 plus 2i. Okay. Let's keep going. Alright, so this one is not in standard form because you don't have one number a plus bi. You have all of this. Anytime you see that, you have to multiply by the denominator's complex conjugate. So instead of 3 minus 2i, remember, complex conjugate was this. A plus bi times a minus bi. So see how it's 3 minus 2i, so that means you multiply the top and bottom by 3 plus 2i. 3 plus 2i. So multiply the top out, 15 plus 10i plus 6i plus 4i squared. Now watch what happens on the bottom here. You get 9 plus 6i minus 6i minus 4i squared. The middle always cancels, so you really only need to multiply the first two and the last two for the denominator. So if I look at the top, I get 15 plus 16i. And then I squared is negative 1, so it's minus 4. For the bottom, those two cancel, and that would change to 9 plus 4, because I squared is negative 1. So now I have 11 plus 16i over 13, which is 11 over 13 plus 16 over 13i. Alright, let's take a look at the next page. Alright, so this is plot the complex numbers in the same complex plane. So here's the thing, complex plane, instead of x-axis, y-axis, it's real numbers are the x-axis, imaginary numbers are the y-axis. So see, I have 3 minus 2i, that's like x equals 3, y equals negative 2. So you go 3, negative 2. Okay? Negative 2, 4. 3i is 0, 3. So let's take a look at some of our own examples, try to graph them. Okay, so you have 4 minus I, so that's like x equals 4, y equals negative 1. So if I go to graph that, 1, 2, 3, 4, negative 1. 2 and 5, so 1, 2, 1, 2, 3, 4. Oh, didn't make a big enough graph there. 5. 4i is 0. 1, 2, 3, 4. Okay? Now, absolute values. Just an equation, so let's take a look. Alright, absolute value of a complex number. The absolute value of a complex number z equals a plus bi is denoted by the absolute value of z. Is a non-negative real number defined as absolute value of z equals square root of the quantity a squared plus b squared. Okay? Because if you look at the real and the imaginary to get that distance, it's a squared plus b squared. It's a right triangle. So if I look at that, it says then find the absolute value of each complex number. So I know a equals 3, b equals negative 4, so plug it in. Okay? So you would get the square root of 9 plus 16 equals the square root of 25, which is 5. So the absolute value of 3 minus 4i, 5. Okay? See you guys tomorrow.